Oh, I have another term to introduce. So you know that compression expansion work that we were talking about? When that gets applied to the piston and cylinder system, we also call it the pressure volume work. So that compression expansion work, when it is applied to a piston cylinder system, is also called the pressure volume work. So you will see it written like small p, big V diagram, or you will see it written as VP on a graph. And we'll discuss this in a second. Now give me a second to explain that. Okay, here we go. Can you tell why this is called the pressure volume work? Is it really clear from this picture? Can you explain?
As pressure decreases, volume decreases.
Good. And as pressure
increases, volume decreases.
There we go. This is called pressure volume work. Now, where does it come from? What is work? Is work F dot dy? Right? Work was displaced force times displacement. If I call this my dy, can I write work as this? What is force in terms of pressure? Pressure is force per unit area. May I rewrite this as PA dy? What is A? The area of piston. Does that change ever? No, the cross-sectional area of the piston, right? Does that change? Or the cross-sectional area of the entire cylinder, will that change? No. What is the only thing that's changing? The delta y, the dy. May I then combine, am I allowed to combine these two and write P dv? A times dy, can I write this as volume? Okay, excellent. Now, Sylvan said something that was really valid. He said, when pressure increases, what happens to the volume? And when pressure decreases, what happens to the volume? How do I show that mathematically? No? How do I show that mathematically? By adding a subtraction sign. So then I said that there has to be a way to express all of this. And we can express this in terms of P and V, where suppose this is your system that evolves from state 1 to state 2. It will go from P1. Well, do you want to go up or down? Okay, so this is your transformation. It'll go from V1 to V2.
Why is it like?
It could be.
Why would it not be? What else can you guys do with it not be linear?
It can be.
Is there a circumstance where it would not be?
Yeah. It could be. It could also be this. It could also be that. And that will answer, I think, Andy's question. So what's going on in this picture if I call this number 1? and this number 2,
2 state 2.
and this number 3. Okay, do you want to do expansion or contraction? Pick one, guys.
Contraction.
How many people want expansion? Okay, good. Okay, that means what? If we have a cyclic process, is 2 going to go like this? And is 1 going to go like that? Okay, what can you tell me about step 1? I'm going to say delta P and delta V. So step 1, look at step 1. What's happening to delta P? Nothing. So delta P is 0. What is happening to V2? Delta V. It's going from V2 to V1. Okay, what about step 2? What happens to delta P? It goes from some P2 to some P1. Agreed? And what happens to delta V? Nothing. What about step 3? What's happening to delta V and delta P? Are they changing?
Yep. Sometime.
At the same time. Excellent. Well, then how do we make it cyclic? Right? Great question. No, it's a good question. How do you make it cyclic? So imagine if I can do what you're saying, right? I could do that. But then how do I make it cyclic? You have to change all the other arrows. Remember I said that, so this is not vector additions.
Right.
So the
That's
way,
why I thought.
so remember what I said here? These are 2 options.